Well, what happened? Two black holes collided a long, long time ago. And the amazing thing is that no humans existed when black holes collided. But while the waves traveled through the universe, Homo sapiens developed on Earth, and by the time the waves reached the Earth, we not only existed, but had developed instruments which were sufficiently sensitive to detect this tiny, tiny vibration of Earth when the gravitational wave swept past.
Where was it? Where was the collision?
Oh, the collision was 400 megaparsec away. We don't know which galaxy it was exactly, but we know that it was 1.3 billion light years away, which is quite far away. But it's very difficult to pinpoint the location exactly because the detectors we have are not very sensitive directionally. So they can point to an arc on the sky where it might have happened, but cannot say exactly that this was where it was.
Could it happen closer to us?
It could happen closer to us. It might happen closer to us in the near future, but we're getting so few gravitational waves at this time that I cannot tell you when we'll see something which is even closer.
Would this be like dangerous for us on the Earth?
This will probably not be dangerous for us unless Earth would collide with a black hole, which is not going to happen anytime soon. But the effect is so tremendously small. And here we're talking about trillionths of a millimeter on a length which is the size of the diameter of the Earth. That this is not something which an ordinary human would even feel. This is why we need these extremely sensitive instruments.
So even when they arrived at Earth, nobody could feel it.
That's right.
Although they went just through us.
So we believe that there are gravitational waves sweeping through the Earth all the time. Now. And if we're lucky and the amplitude is slightly larger, then we are able to detect them. But mostly we are not even able to see them.
What was this sound of the gravitational wave like?
Oh, so the point is, and I want to stress that gravitational waves are not sound. But the waveform has wiggles in them. And if you look at these wiggles and how they vary over time, you can represent what you see in terms of an audible signal. And this was the chirp we just heard. So it so happens that the frequency of these waveforms is almost the range of human hearing. And this is why we're saying that the gravitational waves are loud, that we can hear them.